So we are given the figure and asked to prove that QED and MEX are congruent. To do that, we are either going to need to use these two angles because they share this middle angle here and make a linear pair, or we are going to have to use these two because they share this angle here and form linear pairs. We'll be able to tell from the proof which one we need to use based on the information that's already there. So we have that DEM and MEX are supplementary. So we're going to use those. Because we're going to use those, we know we are not going to use this linear pair because they do not share an angle. We are going to use this linear pair for the other linear pair. So those are a linear pair. The other linear pair is this one because we have to have an angle that is shared. So we can also look down here to see what that's going to be. It's going to be QED and DEM. So we already have the 180 degree statement for that one right there. We need to make the 180 degree statement for that one there. So measure of angle DEM plus the measure of angle MEX is equal to 180 degrees. And that's definition of supplementary. This other one is also definition of supplementary. Now we see that this one and this one are both equal to 180 degrees, so they must be equal to each other. So QED and DEM and MEX, that is transitive property. Now we see that both sides have DEM, and so we can subtract DEM from both sides. That's going to leave the measure of angle QED is equal to the measure of angle MEX. Because they are equal, their measures are equal, they are congruent. That is definition of congruent angles. And that's it for that one. So again, what happened was we proved that these two were supplementary and made 180. These two were supplementary and made 180. They shared this angle, so we subtracted it. And what was left was this angle being equal to this angle. Okay, angle A is a right angle, that was given. Angle E is a right angle, that was given. Measure of angle A is 90 degrees, that is definition of right angle. We also have angle E that's a right angle, so measure of angle E is also 90 degrees. We can now say that because they are both equal to 90, they must be equal to each other. So the measure statement's already there. Measure of angle A is equal to the measure of angle E, that is transitive property. And then from measure to congruence is definition of congruent. I'll pause here if you need to pause the video. Moving on. We have that angle XEL is congruent to angle MAC. We need to prove that angle LEQ is congruent to angle CAG. And it's going to be easy to do that because we're going to say these two add up to be 180, these two add up to be 180, and since these two are congruent, if they add up to the same thing on both sides, the other two must also be congruent, or their measures must be equal. So that's how we're going to set this proof up. We're going to start with what we were given. And we are going to say MAC and CAG are supplementary because they form a linear pair. We're also going to say the other side, XCL and LEQ are supplementary because they also form a linear pair. Now, definition of congruent would allow us to say that since those two are congruent, their measures must be equal. And MAC to CA plus CAG makes 180 comes from here. That is definition of supplementary. Then the other definition of supplementary is going to be the other pair. So measure of angle XEL plus the measure of angle LEQ is equal to 180 degrees. Now, since both of these are equal to 180, they must be equal to each other. So measure of angle MAC plus measure of angle CAG is equal to the measure of angle XEL plus the measure of angle LEQ. And LEQ, CAG, MAC, they do not have anything on both sides that is equal, but we do see that we have XEL is equal to MAC. So I can subtract XEL and MAC from each side because they are equal, which leaves me with CAG and LEQ. That is a subtraction property. And then because their measures are equal, they are congruent because of definition of congruent. Alright, moving on to number 4. We are given that dx is congruent to ZH and that XL is congruent to HC. We are asked to prove that dx plus XL, those two segments, are equivalent or equal to that entire segment over there. We've done lots of these before where it's like, okay, the short one and the long one are congruent to the short one and the long one, so if we add both of those up and we add both of those up, we should get the same thing. We just have to go through the process of proving it. So dx is congruent to ZH, that was given. XL is congruent to HC, that was also given. Now we are going to add up both of these shorter segments to make the entire segment. So ZH plus HC equals ZC. That is segment addition. And because these are congruent, their measures are equal. So we need to make that statement down here. Measure of angle, measure of XL is equal to the measure of HC. Now, because we have that, we can replace let's see what happened. The measure of XL and HC is already there, so I cannot say it twice. What I need to do instead is go up further to the first one and bring it down. So the measure of dx is equal to the measure of ZH. And then the measure of XL and the measure of HC is already there. So now what's going to happen is we are going to begin substituting. We have in our original equation ZH, we can see that ZH is equal to dx, and so we are going to replace dx with ZH right there. So ZH was right there. dx is taking its place right there. And this was definition of congruent. Again, we went from this statement down here for that one. So we replaced ZH with DX because they are congruent. That is substitution. And we have another pair of angles that are equal. They are XL and HC. So what's going to happen is this HC is going to be replaced with XL to make it match what we are trying to prove right over here. So the measure of dx plus the measure, we're replacing HC with XL is equal to the measure of ZC. Lots of substitution, lots of kind of wacky stuff going on in that one, but it's just replacing one line segment with another. I'll leave this here for a moment if you'd like to take notes or any of them. On to 5 and 6. We are given that QAW is congruent to MEX. We are also given that WAZ is congruent to XEG. And we are asked to prove that these two angles together is congruent to these two angles together. Again, pretty straightforward proof. We are going to end up replacing that angle with that one and replacing that angle with that one to say that if I replace them, they are still equal to the size of the larger angle. Let's get to it. We were given that QAW is congruent to MEX. We were also given that angle WAZ is congruent to angle XEG. And because we know we are trying to prove that those two angles over here are equal to the size of the large angle over here, we need to make sure that our first proof has the large angle of what we're trying to prove in it. So MEG, that's why MEG is here. So MEX plus XEG equals MEG, that is angle addition. That angle and that angle were added together to make the larger angle. And because we have angles that are congruent, we can say that their measures are equal. I'm going to be careful though, that one actually is down here. So this one is going to go there. So measure of angle QAW is equal to the measure of angle MEX. Then the measure of WAZ is equal to the measure of XEG, because as we can see a couple rows above, they are congruent, so that is definition of congruent. Now what needs to happen is we need to look for what we are going to begin replacing. So we can see that QAW and MEX are equal. So I'm going to replace MEX with QAW and rewrite that statement. So from here down, replacing MEX with QAW. Everything else stays the same. Now, we are going to look for the other one that we can replace because of an equality statement. We see that WAZ and XEG are equal, so I'm going to replace XEG with WAZ, and that is going to be substitution. So again, we can see XEG and WAZ, the green highlighted ones, were equal, so we replaced XEG with WAZ. Okay, last one, we have given that zi is perpendicular to xi. That was given. We have a linear pair there, zix. Zix and angle xih are supplementary. Zix is a right angle, that is definition, that is because of perpendicular. And then definition of supplementary angles, we're going to bring this one down here. We're going to say that they add up to be 180. Measure of angle zix plus the measure of angle xih is equal to 180 degrees. So, measure of angle zix is 90 degrees. That is because of definition of right angle. And we can say that xih is 90 degrees because what we would be doing is subtracting zix from the left side and subtracting 90 from the right side to be left with xih on the left side and 90 on the right side. So that is subtraction.